There's two different methods for performing an impact test. You choose a set of points that you would like to measure. You can either then rove your hammer, impacting on all those points while keeping an accelerometer fixed, or you can impact at one location and rove your accelerometer to all those points. So let's run through that in a little more detail with an example of a test on a flat plate. So I've got this flat plate here. I've got a impact hammer and an accelerometer as my force input and my response, and a data acquisition device that has at least 2 channels. So I will be measuring at each of these 9 locations here, and we'll do one scenario where we perform a roving hammer test and one scenario where we perform a roving accelerometer test. So to perform a modal analysis, to actually curve fit and extract information from our FRFs, we need one complete row or one complete column of this table. So this table is the possible inputs and the possible outputs of our structure. So we are impacting at 9 points here. So I have F1X, I can input in the X, Y, and Z direction. And then I go from 1 to 9. And I can also, at each of these 9 points, measure the response in the X, Y, and Z direction at all the points. So I go from A1 to A9. In order to get complete mode shapes, I need either one row or one column of the table of my possible inputs and outputs. So let's talk about a roving accelerometer test. To start off, I'm going to place my accelerometer at point 1, and I will impact at point 1. When I do that, I get this information in the table. And I should also mention that we're going to be impacting in the Z direction. I will then move my accelerometer to point 2 and perform an impact at point 1. So I now have this information in my table, A2X over F1Z, A2Y over F1Z, and A2Z over F1Z. And I can do the same thing at all of my measurement points. So going from point 2 to point 3 here, point 3 to point 4, up until point 9. And what I get is a complete row of my input and output table. So it's able to calculate, or I'm able to calculate, the complete mode shapes in the X, Y, and Z direction of my structure. Let's change that to a roving hammer test. So now I will keep my accelerometer fixed at point 1, and I will rove my hammer hitting in the Z direction, points 1 through 9. So if I impact at point 1, I get this information in my table. If I then move my hammer to point 2 and impact in the Z direction, I get this information here, and I can do the same thing, impacting at all of my points until I have impacted at each point. And I don't have a complete row or complete column in my table here, so I cannot calculate the complete mode shapes of my structure. I can only calculate the mode shapes in the Z direction, which for some tests might be enough. You might run a modal test with the intention of only measuring mode shapes in a specific direction, because from prior experience, you know those are the important mode shapes to determine. In order to capture all the mode shapes in this roving hammer test, we would need to hit in the X, Y, and Z directions at each point. So because of that, if you're trying to determine the complete mode shapes of your system, it's usually easier to perform a roving accelerometer test, because there will be certain points on this plate, for example, this point in the middle, where it's impossible to impact in any direction other than the Z direction.